Hello everyone, this is part 2 of how not to write papers and presentations. If you haven't seen part 1, please go and see it. Thank you. Right, we're talking about microstructures, and these are usually a very important part of materials scientists and other mechanical engineers and sometimes chemical engineers and chemists' work. So we do really good work with microscopes, scanning electron microscopes, transmission electron microscopes, optical microscopes, and now what we want to do is record our work so that other people can read it. And remember, this is about presentations like the one I'm giving now, and written work like papers, conference papers, dissertations and theses. So all this applies. Right, the first thing is have a micron bar. There's the micron bar, and it should be a bar, and it should say how long that bar is. It's really important you have that bar, because otherwise you don't know how big things are. Sometimes if there's a problem with getting the micron bar, then you must work out, some people describe the length of this, the full width, and they give a measurement to that, how much that is. So that's really important. And then you must keep the original aspect ratio. And if you look at this, the aspect ratio would be the height to the length. You mustn't change that. I know it's very easy to change it in modern software. In the old days, when I started doing my research, we had negatives, and you'd have to really try to change that. You could do, but it would be really difficult. So these days, it's just so much easier to change it, and you mustn't. That aspect ratio must stay the same. Now, one thing which irritates me is sometimes people will show a big picture of something and then they've got an inset, and if you look at these are different shapes, so the person isn't thinking. They should have drawn that to be more of a rectangle. It looks more like a square. I think the aspect ratios are correct, because they've got the same aspect ratios, but they might have changed the whole thing, so maybe both aren't correct. Here's some micrographs which have been squashed. If you look at this, these are all roughly the same height, and these all come from a Zeiss instrument. That comes from something else. Okay, and what I don't like here is, if you look at this, all of these have had their aspect ratios changed, because the writing, I know it's small on the screen, the writing is a bit squashed. But if you compare these, and they all came from the same publication, or would-be publication, you can see that this is narrower than that, and these two are narrower than that. So they've been squashed, and they haven't even been squashed to the same amount, so they look different. Over here, there's no micron bars. Don't know what's happening. How big is that? Is it huge? Is it little? We don't know. This irritates me, because they've taken a they've taken an analysis of this area, and you can't really see anything. Okay, I've made it very small, but it's better to give numerical values, and there's actually two different contrasts in there, so there's probably two different phases, and they might be kidding themselves what they're actually measuring. You can get yourself into a real mess. Remember, in the last presentation I talk about analyzing the sizes of things. You must analyze things that are at least 2 microns across, so that you think you are analyzing what you think you're analyzing, and it's very easy to fall in that trap. Here's a micrograph that isn't even in focus. Okay, very bad. Always have things in focus. Okay, here's a little bit more about aspect ratios. So here's me, okay, standing against the wall, hopefully not waiting to be shot, and I've got a ball which I use for teaching, and two 30-centimeter rulers. Here I am squashed. Okay, I've changed the aspect ratios. so I look fatter. Here I am, extended, so I look like a supermodel. Both of these are wrong. And this is trying to get across to you why you mustn't change the aspect ratios. Okay, more microstructures. Sometimes people will have a figure that's built up of many figures showing different samples or different features in the sample. And don't have them at different magnifications if you're showing different samples. Have them all at the same magnifications so people can compare. Remember, you're trying to communicate. You're not trying to hide things. You must state how the images were taken, but make sure it's correct. This, normally you would put that first, but on this example, what we've got is a particular specimen. Hopefully this would be defined in the paper. So you're saying there's an image of the fracture surface, image of the polished surface, the spectrum, I prefer EDX, but never mind, and an XRD pattern. But it all relates to that specimen. But it's nice and clear what's going on. Graphs. Give the units, always give the units. It's a waste of time not to give the units, okay? Use sensible scales, always have error bars because then people can see what is comparable to what. And if something is bigger, is it really bigger or do the error bars overlap? Don't have too small, don't have too large of anything, the graph, the writing, what's drawn on it, and just have relevant graphs. I once saw something where they just kept plotting the same graph in different ways. I thought just to fill up space, but maybe I was being nasty. Right, so here's some examples of some graphs. So here we've got, it says time hours, and then the person has put in hours and all those. You don't need to do that because you've got that. Okay, now if you look at this, you might think, okay, we've got all these samples. You were basically they were adding an inhibitor in, and that is that's from a biological plant. So this is a species name. That should be a capital. This should all be in italics. Molar. It's not 1 meter. It's molar. So that should be uppercase. Should be a space between there to make it clear. And then what they've got is obviously as they're adding the inhibitor in, you've got less weight loss, so that looks good. But the trouble is these are all very similar, so what it would be a good idea to do is draw these on a separate graph with standard deviations, and then you could really see, was there any real difference or are they much of a muchness? Okay, aspect ratios again. Don't squash ternary diagrams in any direction. They should be equilateral triangles, and I see this so many times. So this one's squashed and this one has been extended. Okay, it's supposed to be an equilateral triangle. Okay, don't fiddle things. This was a paper I was reviewing, and if you look across there, it's the same surface, okay, so it's the same area. They said they had no porosity, but you could see porosity sitting there. So I wrote when I wrote my report on the paper, I said, how can you say there's no porosity when you've got porosity there? So the second version came back. They'd obviously magically got rid of the porosity. If you look a little bit, you can see it's still there, but they've used some technique on the micrograph to get rid of the porosity, and it's not a good idea. And while we're here, rather not put the magnification on, just have the micron bar. The reason for that is that the magnification depends on how big it's printed or put on the screen, or you're probably watching this on a computer, how big your computer screen is. So that magnification isn't going to be correct. Okay, so rather just put the micron bar on. Tables. Tables are great because you can put lots of information in them, make it really nice and clear, and it's easy to read. But Don't have too many columns to be readable. Don't have a column that's got values that don't change. That's just taking up space. Always give the units. Or use the proper abbreviations, and we're expected always to use SI units. There's a few things that you can get away with, and if you're comparing with others' results, give the references so the reader will know which is yours and which is others and where they can find those other results if they want to read more about them. And then always define things clearly. Remember, writing is about communication, and it's about being succinct and about being clear. Okay, so we've got this stuff again. They've got this, it's a species name, so that's the genus, that's got uppercase, that's a species, that's lowercase, and it's italic. Great. Now what's going on is you've got time, hours, and you've got this blank. Now presumably this blank is supposed to be there, but is it necessary? Okay, because it's a column with not showing very much. And yeah, they put the tables and the graphs. Okay, so do you really need both? Probably not. Okay, and this is from the same work, and what they've got, now this is really bad. You can tell I went to town on this. If you look at this, you've got things going over lines. That should say constituent, alkaloids, cardiac, and so on, tannins. Everything goes over the line. Now what they should have done was they could have rotated this through 90 degrees. Okay, then you would have got all of them in. And then they've got this funny table, okay, where they've got pluses. So 3 pluses is present in an appreciable amount. But what does that mean? What's appreciable? Okay, present in a moderate amount. What does moderate need? Present in a minute amount. What does that mean? Give some values. Give some percentages or something. And then they've got negative, which is absent. Okay, and negative doesn't actually mean absent. Negative means a negative number, but they don't use that. So this is horrible. It's not clear. You've got to define these. This isn't clear. That's not clear. It's horrible. Discussion. Now, what a lot of people do is, no, that's unfair. What some people do when they're first starting off is they just repeat their results. Okay, no, that's not what they're doing. That's not what you should be doing in a discussion. The results are where the results section is where you give your results. Your discussion section is where you try and work out what they mean, and you compare them with each other, and you compare them with those in the reference literature. You might find new literature as you discuss things, but that might be to explain something, but you shouldn't be bringing in new comparisons or new results that aren't from someone else that magically appears in the discussion. The sort of thing which you might have in the discussion that you don't have in the introduction is if you're trying to explain something about the technique. Try and explain things. Now, this was a real one. The current calculations were compared with the experimental data, and then gives a very nice ref, and yes, that's me, and the experiments were wrong. Well, how do you know that? So I said, no, you can't put that, not just because they were our results, but you've got to be more, you've got to explain more than that. So this shows no agreement with the current calculations. Bad English here, but not all the conditions were known, so perhaps the experimental results cannot be directly compared. Well, that's better than just saying that your supervisor's experimental data were wrong. Okay, conclusions. 2 traps that people fall into. Be concise. Different people have got different ideas of what they put in the conclusions. Some people like to put an overview of what they've done, which is fine, but it's got to be concise, okay? Other people just like to put in the results. But a big no-no is you mustn't include new things, okay? Everything in your conclusion must have been said before, and in your conclusion, you are just summarizing it. Okay, so if you're writing a paper, give all the authors. The student should go first, if it's their work, unless it's a review. So quite often, if I'm writing a review article, I'll put myself first and then the students later, okay? But the students have always managed to publish something before I'll do that. My help, of course. If you've paid somebody for the service, then you can acknowledge them. But if they've contributed something and you haven't paid them, then you should include them as an author. Get the affiliations right, okay? That's a real pain and it can upset people, because get your university right, because your university gets recognition for this, and all our universities want recognition. So if we don't put the affiliations right, they won't get that affiliation. And even if you're having a bad time with your university, they are providing you a space to work in. And then acknowledge the right people, okay? People who helped you, not your pet, no matter how adorable it is, okay? That's not my pet, I was helping it. And then once again, thanks to my students and various journals for which I review, because without you, I wouldn't have a job. And these are all the nice things I get from my job, although sometimes I wish I'd stayed in bed. Thank you very much.